Hello everyone, thank you for joining me today as we discuss linear equations with two objectives, those being to graph linear equations given in different formats and identify the slope and intercepts of various linear equations. Now, before we talk about the different formats of these linear equations, let's talk about the key characteristic of this family of functions, and that is their constant slope, their constant rate of change, giving them this linear appearance, always either increasing or decreasing by the same rate, the same amount as we progress along the graph, okay? Now, the slope describes that rate of change, and we can calculate the slope of a line using the formula in the box there. We're finding the vertical change over the horizontal change, the change in y over the change in x, as you may have heard it described before. And we can get various types of slopes when we do that calculation. A positive slope, where the line goes up to the right, a negative slope, where the line slopes down to the right, a horizontal slope of 0, or a perfectly vertical line will have an undefined slope, and we'll encounter that here in a little bit. Now, the image on the right-hand side, the little cartoonish looking character, is just kind of a way to kind of memorize those slopes. We got a negative slope going down to the right, positive slope going up to the right, a U underneath his nose there, an undefined slope is a perfectly vertical line, and a slope of 0, the dimples by his mouth there would be a perfectly horizontal line. With that being said, now let's practice calculating the slope of a line that passes through the given pair of points. And let's start here with negative 3, 9, and 0, 3. So our slope calculation is the change in y over the change in x. Most people would say y2 minus y1 over x2 minus x1. 3 minus 9 being negative 6, 0 minus negative 3 is really 0 plus 3. We get a slope here of negative 2 over 1. This is a decreasing linear function. Let's try here. Negative 4, negative 3, and 7, comma 1. Again, change in y over change in x. Now, just to prove a point, you could consider this to be your y2 and this your y1. If you do that, though, you have to make sure this is your x2 and this is your x1. We've got to keep that labeling consistent. So I could say negative 3 minus 1. Then I could say negative 4 minus 7, change in y over change in x. That's negative 4 over negative 11, which would be a positive 4 over 11. Graphically, this is an increasing linear function that goes up 4 and to the right 11. One more example here, the line that passes through 2, 8, and 2, negative 5. We'll find our change in y over our change in x. And this is where we get something kind of interesting. We get a 0 in our denominator. Now, a 0 in a denominator indicates that this is an undefined expression. This slope here is undefined. Graphically, that means that this line is perfectly vertical, which makes sense because there was no change in x. There's no run here, 2 minus 2. It goes straight up and down, perfectly vertical line here. So that's how we can calculate slope between 2 points. So now that we know a little bit about that hallmark characteristic of these linear functions, let's talk about the various formats, starting with perhaps the most popular format, that slope-intercept equation, y equals mx plus b. This format is particularly useful when we have the slope and the y-intercept, in terms of a word problem when we have the rate of change and the starting amount. So y equals mx plus b, where m is the slope and b is the y-intercept, where that line crosses the y-axis. Let's just practice working with that format, and let's write a few equations in that format. So here, write an equation with a slope of 3 and a y-intercept of 0, 2. While using our y equals mx plus b, that will be y equals 3x plus 2. Here, a slope of 5/6 and a y-intercept of 12 would result in this slope-intercept equation. Here we have a slope of negative 5 and a y-intercept of 0, and you very well could keep the plus 0 here for that y-intercept, but we wouldn't need to have it. And finally here we've got a slope of 0 and a y-intercept of negative 4. Well, you could say y equals 0x minus 4, or you could say 0 times x is 0, and so we'll just have y equals negative 4. This would be a perfectly horizontal line with a slope of 0 passing through the y-axis at negative 4. That is the slope-intercept form of a linear equation, y equals mx plus b. So now that we know how to write it, let's practice graphing it. starting with y equals negative 3x minus 1. Well, remember this minus 1 is our b, our y-intercept. That's our starting point. And so if our y-intercept is negative 1, let's put a point on the y-axis at negative 1. This negative 3 is our slope, our rate of change. And I know negative 3 is not written as a ratio, but we could write it as a ratio so that we have a rise over run. In this case, negative 3 over 1. So we're going to go down 3 and to the right 1 to get a new point. And that's down 3 and to the right 1 from our y-intercept. We could do that again to get another point, and if you wanted to make your line even more accurate, you could do the same pattern in the opposite direction. My lines are hardly ever straight on here, so please bear with me on that. Here, y equals negative 4x plus 5. Our y-intercept is positive 5. 1, 2, 3, 4, 5. Here we've got a slope of negative 4 over 1. Okay, so we'll go down 4 and over 1, down 4 and over 1. At a minimum, you need 2 points. Here I've added a couple more just to try to make my line more accurate, even though it doesn't look like it. Did the best I could there. Okay. Now, please note that both of these examples have negative slopes. They won't always have negative slopes. We'll see various examples of that throughout this lesson, so I'll leave it at that for now. This is how we graph that slope-intercept equation. Y equals mx plus b. So what are the other formats? Well, another format for linear equations is the point-slope equation. This is more useful when we have the slope and not the y-intercept, but rather some random point. Our format here is y minus y1 equals m times x minus x1, where x1 and y1 are the coordinates of that random point. M is the slope of that line. Please note that this equation has those minuses built in, so we've got to be extra careful when we're plugging in negative coordinates. Please also note that this form really comes from that slope formula. It's a version of that, and so you can make that connection to the earlier part of this lesson. So let's practice writing point-slope equations. Starting in the top left there, a linear equation with a slope of 3 passing through the point 1, comma 5. We don't have the y-intercept here. We don't have 0, comma blank, and so we can't use our slope-intercept form right away, but we can use this point-slope form right away. So, zooming in on this now, this is our format, y minus blank equals blank times x minus blank, where we have to fill in all of the blanks. Well, our slope is 3, that goes here. The x-coordinate of our point that the line passes through is 1. The y-coordinate of the point that the line passes through is 5. There you have it, y minus 5 equals 3 times x minus 1. Trying this example here, again, setting up our format. Our slope is negative 3/5. The x-coordinate of the point we are given is negative 4. The y-coordinate to the point we are given is negative 2. Notice here we've got some minus negatives, and we do want to clean those up to call this y plus 2 equals negative 3/5 times x plus 4. Note that the coordinates were negative, and yet the formula appears to be positive. We've got to be extra careful with that. Now on this last example, we are not outright given the slope, so our first step would be to calculate this, and to speed up this video at least a little bit, when you go to calculate that slope, you will get a slope of negative 1/4, change in y over change in x. So now when it comes time to write our equations, we've got a slope of negative 1/4. If you're wondering which of these ordered pairs to use, that's a good thing to wonder, and it turns out that we can use either one. But what we can't do is we can't mix and match. We can't use this coordinate and this coordinate. We've got to keep it consistent. So say that I choose to use this ordered pair. Our x-coordinate is negative 10, our y-coordinate is negative 3, and just like we saw previously, we'd want to clean up those minus negatives there to get this. If you had chosen to use the other ordered pair, your equation would have turned out y plus 5 equals negative 1/4 times x plus 2. Both of these answers are perfectly acceptable because both of those points are on this line. So that's how we write a point-slope equation. So then how do we graph it? Well, just like with slope-intercept form, start with the point that you have and then use the slope to progress from there. So taking a look at this equation here, the first thing we'd want to do is pull out the coordinates of our point. And since we have a plus 3 here, our x-coordinate will be negative 3. A minus 2 tells me our y-coordinate is positive 2. So we'll put our point at negative 3, comma 2. Now our slope is 4/3. So from that point that we just graphed, we are going to rise up 4 and run over 3, and that takes us right here. That's enough to graph our line, but I'll be a little bit more accurate, at least give myself a better chance by using that same pattern in reverse to get one more point that the line passes through. Trying this example here, first the coordinates of our point would be 1, -5, and our slope will be 3, or 3 over 1 if that's helpful. So 1, -5 here, a slope of 3 will go up 3 over 1, and I'll do that a couple times just to, again, help me to draw a more accurate line. It's not great, but it'll do. So the point-slope equation, useful when we were given the slope, and not the y-intercept, but some other random point that the line passes through. Finally, then, let's get to our last format today, and that is the standard form for a linear equation, ax plus by equals c. In terms of graphing and writing, this might be the most cumbersome of the formats that we have. However, it is useful to find the x and y intercepts quickly. It can also be useful to model plenty of linear real-world scenarios, word problems, basically. Now, in this format, a, b, and c are integers, positive or negative whole numbers. A few examples are shown on the screen here. 4x minus 3y equals 12, negative 2x plus 11y equals 25. Now, one skill that we are often asked to do is to take an equation and turn it into standard form. So consider this slope-intercept equation here, y equals negative 3/4 x plus 5. If the goal is to turn this into a standard form equation, we got to get x and y on the same side, and we need all of our coefficients to be integers so that we have a standard form equation. Well, starting by getting x and y on the same side, one way that we can manage that is to take this negative 3/4 x and add it to the left-hand side. Add it to both sides, I should say, but keeping it balanced, but then moving it to the left-hand side. So then we have 3/4 x plus y equals 5. Now we're close here because we have x and y on the same side, but remember a, b, and c have to be integers, and 3/4 is not an integer. To make it an integer, we can multiply both sides of this equation by 4, the number in the denominator there, because when we take 4 times 3/4, effectively these 4's cancel out, leaving us with just 3x. So now we have 3x, and don't forget to distribute that 4 to that y, and also don't forget to multiply the other side by 4. Here now we have a standard form equation, 3x plus 4y equals 20. To be totally transparent, if you graphed both of these, they would look exactly the same function, same graph. They're just written a little bit differently in different formats. So again here, now that we know kind of what standard form looks like in terms of how it's written, let's talk about how we can graph it. There's a few different ways you can. You could take a standard form equation and manipulate it into slope-intercept form, y equals mx plus b, but I don't think that's the fastest. I think for an equation like the one on the screen, the fastest way to go is to find the x and y intercepts, plot those, and then connect them to form our line. Let's try that here. Let's find the x-intercept first. We've got negative 3x plus 5y equals 15. To find our x-intercept here, well, the x-intercept is where the graph crosses the x-axis. At that location, the y-coordinate will be 0. So to find an x-intercept, we plug 0 in for y, and we solve for x. Now, 5 times 0 is 0, so that expression drops out. We divide both sides by negative 3, and we find ourselves the x-intercept of this line, negative 5, 0. I'm going to go ahead and plot that on the graph. Let's find the y-intercept. This is where the line crosses the y-axis. Well, at that location, the x-coordinate will be 0. So to find the y-intercept, we plug 0 in for x, and we solve for y. Well, negative 3 times 0 again drops out. We divide both sides by 5 to find that the y-intercept here is 3, 0, 3. Plot that on our graph. 2 points is really all we need to draw a line, right? And so there we have it. We have just graphed this standard form equation, negative 3x plus 5y equals 15. So at this point, we've discussed a lot. We've discussed slope and then 3 different formats for linear equations. The last topic that we'll hit just quickly here is this concept of parallel lines and perpendicular lines. Parallel lines have the same slope. Okay, in a geometry perspective, they'll never touch, they'll never cross, right? Well, algebraically, that happens because they have the same slope. They're always increasing or decreasing by the same amount, and thus they will never cross, they'll never touch each other. Perpendicular lines, on the other hand, do intersect. They have slopes that are opposite reciprocals. From a geometry perspective, they cross at a 90-degree angle, at a right angle. So how might you be asked to use this concept? Well, to speed things up a little bit, we'll only do one of these examples. Here we've been asked to write the equation of a line, a slope-intercept equation, that passes through the point -3, 1 and is parallel to y equals -2/5 x minus 4. Well, to write a linear equation, it's helpful to have a point, which we have, and the slope, which we can get. Because if we know this line is parallel to y equals -2/5 x minus 4, parallel means our lines have to have the same slope. So if this line has a slope of -2/5, then the line we're trying to write has to have a slope of -2/5. Now the tricky part here is that we're asked to write a slope-intercept equation, but we don't have the y-intercept. There's a few different ways we can work with this. I'll go through one of those ways here, again trying to shorten this video even a little bit. We do have a random point that the line passes through in addition to the slope. So we could go back to our point-slope equation and at least start there. If we do so, we will have y minus 1 equals -2/5 x minus -3. And if I clean up my pluses and minuses, we'll have an x plus 3 over here. To turn this into slope-intercept form, y equals mx plus b, well, we got to get everything over to the right-hand side, and we need these parentheses to go away. So I'm going to distribute these -2/5 to make that happen, giving us y minus 1 equals -2/5 x. -2/5 times 3 would be a -6/5. And in order for this to be in the form of y equals mx plus b, we need the y by itself over here, and we can accomplish that by adding 1 to both sides. Now, if I want to add 1 to -6/5, I'll need a common denominator. I can turn 1 into 5/5, and if I add 5/5 to -6/5, I'm going to have -1/5. So here we have a line that's parallel to -2/5 x minus 4, but this line passes through the point -3, 1. That parallel nature there helped us to identify what the slope of our line needed to be. A perpendicular example would be very similar. Just recognize then that your slopes would be opposite reciprocals, kind of like these two up here, a slope of 2 and a slope of -1/2. That was a lot of information. Thank you for sticking with me here as we discussed linear equations. We discussed slope. We discussed the various formats. We graphed them. We wrote them. We found their intercepts. Thank you for watching.